I'm going to begin by just giving you guys a little bit of background information about me. So I grew up in Pennsylvania. I'm currently a senior at Duke University, graduating in December. I'm studying computer science, English, and philosophy. Last summer, I had the opportunity to do an internship at Goddard Institute for Space Studies, which is a satellite campus of Goddard Space Flight Center, and I'll be going back there again this summer to the same team. And so the internship that I was working on, project was the research scanning polarimeter, which is an important remote sensing machine that NASA operates to gather data on its Earth science, on atmospheric chemistry. So a little bit about what a polarimeter is. Polarimetry is the study of the planes on which light polarizes. So just as visible light has a number of different wavelengths in it, which is obviously like the distance of a wave, the distance between one cycle of the wave and the next cycle, there's also a number of different polarization angles. So those waves will also polarize at different angles and on different planes. As you can see in the bottom right-hand diagram, there's horizontal and vertical waves shown here, but there's really there's a complete spectrum of angles at which light vibrates, light particles vibrate, and polarimeters, they capture the angles at which there's different polarization occurring. So this image shows a polarized material, like, for example, that you might see in sunglasses, which will only allow light of a specific polarization angle through the substance. The polarimeter itself, like I said, is measuring the different angles at which light scatters. And it's a scanning polarimeter because it hangs out the bottom of the plane, and it will rotate like this and gauge the polarization of light at all different angles along its axis of rotation. And so why polarimetry matters is the next thing that I want to talk about. And polarimetry is important because just as, again, I am returning to the wavelengths analogy because it's something that people understand a little bit better. So just as there's different substances will emit different wavelengths of light, different substances will cause light to polarize differently. So different molecules and different particles in the upper atmosphere will have distinct and unique polarization signatures. So just in the same way that astronomers can tell the chemical composition of a star from the different wavelengths of light that it emits or doesn't emit, atmospheric chemists can tell the composition of the atmosphere by the different polarization angles of light that's being gathered by the research scanning polarimeter. So the bottom line is it's vital data for climate science research. And my job was to increase and improve the software functionality around the data management structure and system that was in place. So I had two main opportunities and projects to work on this summer. One was more front-end web development. So there's a website that NASA operates where all of the different data for the research scanning polarimeter is accessible to the public. And then there's also integrating an app that the team had built in the past, which would allow for near real-time monitoring of the data that the research scanning polarimeter outputs during its flights on any laptop computer. So I had to, one, work on building out functionality for the website, and then two, moving the code for the live monitor online, because in the past it was just something that was on the scientists' computers themselves. So the first thing was, like I said, the web development aspect of it. This is a screenshot of the website. It's got a basic map, and you can plot the different missions that the research scanning polarimeter has flown on. So I worked on increasing the functionality for this and making it easier for scientists who are browsing data and deciding which files to download to get a more versatile and robust picture of what they're going to be downloading and exploring before they actually download it. So I increased the taskbar functionality. I also put in filter functions to allow for some analysis of the data to happen before you actually download the data itself. And there were a couple of other things that, just in the interest of time, I'll have to gloss over. And so the live monitor was probably where I spent more of my time, because that was sort of the main thing we had to work on this summer. So I started with really, really basic functionality that hadn't really been adapted for the internet very well. So this is a screenshot up here of the sort of layout that I started with. And I worked on data pipelining for this. So what I worked on was making the process by which data is imported into this application more efficient, and also increasing the number of ways that it's displayed. So I was working more on the back end of the processing here. So there were a number of things I worked on. Specifically, I tried to increase the richness of the graphs. So working on getting more data into the same graphs as before, and also increasing the number of ways the user can interact with it. So for example, there were scroll bars and different things that didn't really function at the start, and I fixed those, and also, like I said, increased the number of increase the number of parameters you could use to manipulate the data in real time without refreshing the page, and also without downloading any code again. So yeah, this is just sort of summarizing what I worked on. I did a lot of website upgrades for the website itself, and this was mostly on the front end. And then for the live monitor portion of it, I did more upgrades for the back end and the front end. So I increased the efficiency of the code and the sort of dynamism of the website as a whole, and also changed the way that server calls were done in different variables without getting too jargony, and also developed new code that allows users to interact with the data in new and different ways. So this is a flow chart of sort of the overall function of the live monitor website itself. So all of the different processes it's calling when it receives new data. And yes, so what's next? Like I said, I'm going back to the RSP team this summer, and I've been in touch with them somewhat about what they've worked on. One of the big things we've been working on was developing an app that would allow a lot of this to take place on smartphones. So scientists who are flying in the planes that the RSP is flown on are able to sort of monitor in the most immediate terms possible exactly what's going on in the RSP while it's happening. So increasing the functionality of the app, and then also adding new functionality to those existing websites, and sort of deepening the analysis we can do just online. So yeah, I just have thank you to all of my different mentors and the people that I worked with at NASA this summer. It was an incredible experience, and I'm really, really looking forward to going back. And I can't describe how thankful I am for Space Grant for making all of this possible, because it's been an absolute blessing. Thank you, guys.